I'm sure you've heard of the Big Bang, but what is it really? Well, astronomers have combined mathematical models and observations to develop some theories of how the universe actually came to be. Today, NASA uses things like the Hubble telescope in space to measure exactly how fast the universe is expanding. So in this picture that's provided to us by NASA, if you look to the very left where it says inflation and quantum fluctuations, this is where the inception or beginning of the universe is represented. According to some theories in physics, if we were to look back to 1 second after the Big Bang happened, we would see a giant sea of 10 billion degree protons, neutrons, electrons, anti-electrons or positrons, photons, and of course don't forget neutrinos. Now, protons and electrons and neutrons are probably some familiar vocabulary for you, but if you want to find out about things like neutrinos and anti-electrons, you're going to have to listen to or read a physics book. Before we move on, I want you to look in the top left corner where it says afterglow light pattern, 380,000 years. That is also known as background radiation, and we're going to come back to that in a little bit because it's one of the evidences for the Big Bang theory. So the Big Bang wasn't actually necessarily an explosion. It's more like the opposite of what you'd expect something to do when it starts cooling down. It expanded. This was due to the formation of protons, neutrons, and electrons. This burst of expansion is actually called inflation. But this theory isn't completely bulletproof. There are some holes in it. For this inflation to have taken place, the universe would have had to have been filled with some kind of unsustainable energy form which we haven't quite figured out yet. Nevertheless, scientists have been able to use redshift blueshift to determine how fast the universe is expanding. And turns out, some of the universe is actually expanding faster than the speed of light. So rewind a little bit. Back before the universe started cooling enough to form atoms, the protons, neutrons, and electrons were just free to go wherever they want and do whatever they wanted. It's like a child when his parents aren't around. All the energy in the world and no rules. 10 million degrees of energy, that is. As the universe started cooling, these free electrons actually caused photons to scatter throughout the currently expanding universe. And those leftover light particles can actually still be observed today as the background radiation. NASA has actually launched 2 missions to study the cosmic background radiation. The picture you saw before was actually a picture of the universe when it was only 400,000 years old. Figuring out how to detect these wavelengths of light was not very easy. Needless to say, some Nobel Prizes came out of it. We mentioned earlier that there were some mysterious energies involved in both the creation of the universe and its expansion today. We would normally think that as things coalesce and create greater gravities, the more matter they accrue, that things would start to come back together. But actually, things are still going apart, or rather pushed apart, even faster. This stuff isn't like matter, and it's not like normal energy. And because the unknown is dark and scary, I guess we decided to name this stuff dark matter and dark energy. It's what we think is currently causing the universe to expand faster than the speed of light. We don't actually know what it is or how it works. However, if you subtract the matter that we know about and the energy that we know about from all the rest of space, you get these figures here. As you can see, most of it, about 74%, is the dark energy, 22% dark matter, and the rest, well, stardust and us.